Hey, SV Math Teacher here again, reminding you to like and subscribe if you appreciate what you see. Now, with that said, let's go with writing an equation from a graph for this video. Now, I do have another video out there. I'm going to try to put some links either in the description or as a clickable option for you here on YouTube, but let's make the most of what we can here in a single example where I give you a graph and I want you to write an equation based on what you see. So here comes the example. All right, I have time in hours after midnight and degrees Fahrenheit. Well, it's a sunny day now here in the summertime, and as time goes along, right, what I know about when I wake up versus when I eat lunch, it keeps getting hotter and hotter, and I think that's what this represents. Now, we could probably argue that at some point this temperature probably evens out a bit or even decreases, and that would be completely reasonable, but that's not what we have in the graph, so we're going to ignore that kind of logic, and we're going to go with what we see here. It says write a function in the form y equals mx plus b that represents the graphed line below. So I have a series of questions that if we can answer them all, I think we're going to have our answer. First and foremost, what is the y-intercept? All right, you might recall that the y-intercept is where my line touches my y-axis. It's this point right here, looks like 65, and I also remember that my y-intercept gets the variable b, so 65 is b. What does the y-intercept represent? Okay, so for this, it's a slightly different question. What I'm going to do is I'm going to go left and I'm going to go down and I'm going to see what I run into. So this dot represents two things. It represents what's happening at 0, which is 0 hours after midnight. So that means at midnight. And now I'm going to look to the left to see what else it tells me. 65 is this, so 65 degrees Fahrenheit. So at midnight, it is 65 degrees Fahrenheit, right? So that's what the y-intercept tells me. Let's keep going. What's the rate of change? Now the rate of change, I'll switch colors to let's say green. The rate of change is otherwise known as slope. So what you might recall for some other videos is you're trying to find 2 points where my line touches the grid, and I see 2 points marked in black, so I'm going to go ahead and not stress that. I'm going to use them. In this one, I have some scaling going on, so I'm going to have to be attentive to that scaling. I'm going to rise. Now, that goes from 70 to 75, so my rise is up 5, and then I'm going to run this way. Now, that's running from this spot the whole way to here. So this is about a 6, and it goes from 6 to 12, so 6 to 12 is 5 over 6. Okay, so my rate of change is 5/6. And now what does the rate of change represent? Well, the rate of change is, well, it's the change in y over the change in x. And I show that because the change in y over the change in x. So here's what this tells me. We increase 5/6 of a degree Fahrenheit every, now here comes this, every x, right? Every x is every hour after midnight. So every hour. So our temperature is increasing 5/6 of a degree, or almost a whole degree, every hour. Now write a function in y equals mx plus b form. All right, so I'm going to grab two pieces of information. I'm going to grab my slope and my y-intercept, 5/6 and 65. And we're going to write y equals 5/6, always the x, plus, unless it's negative, and then we put minus, and 65. Right, there's my equation. Is this function linear? So yeah, it's definitely linear. We can see that it's linear because we look at the black line at the top, and it's a straight line, so that's one reason why it's linear. We can say that it's linear because it fits into a linear model. So I'm going to definitely just say yes, and for my explanation, you're hearing me say two different reasons. It fits into the equation, and it also graphs as a straight line. So we're in good shape there. Now, the one thing I don't have in this video, and I should, is some sort of prediction. So if I wanted to make some sort of a prediction, which is also helpful, I might say, what will, you know what, I'm not going to write it, I'll just say it to you. What will the temperature be? So temp equals blank when time is, and let's just go ahead and kind of pick a time, right? So according to this graph, what would happen if the time is 20? So that's 20 hours after midnight. So I'm just going to go ahead and put a question mark. So we could do two things. We could continue to extend our graph out, right? This is kind of the cheater way to do it, but you could do it. We could extend our graph out. We could come up from 20. We could come over. And if my lines snap as straight as I can make them, we can take a guess at probably somewhere around 82. Sounds like a pretty decent guess. Or, and the video is starting to run a little bit long here, but check this out. Or take your equation, which we found right here, and we put 20, which goes along with x, right? 20 is the number of hours. That's our x. We put the 20 in the x spot. So I'm going to erase the 20. I erased too much. Let's erase the 20. I erase the x and put the 20 in there. So now that we put 20 in the x spot, now we're going to multiply. I'm going to take 5/6 times 20. I'm going to take my 5 times 20 and get 100 divided by 6 plus 65. I can't immediately tell you what 100 over 6 is. So I'm going to go ahead and use a calculator, right? You might do the same thing. So 100 divided by 6 is, well, there you go, 16.6 repeating. So 16.6 repeating plus 65, and that's going to be, let's see, 75, 81, 81.6 repeating is going to be our predicted temperature, right? So 81.6 degrees Fahrenheit. Makes sense as a prediction. So with that in mind, check out some of the other videos I might have on writing an equation from a graph. If you're just looking for that skill, this video is designed to give you a little bit more of an all-encompassing look at the information you can pull from a graph.